All right, what we're working on today is graphing systems of inequalities. So let's remember, first of all, what happens with a dotted line. If I have a y is greater than or a y is less than, I'm going to have a dotted line. A solid line is when they're greater than or equal to or less than or equal to. And then there's also shading above. So if my line goes up this way, shading above is over here. But if my line is falling, then shading above is over on this side. And remember, we don't do left or right. We only do above or below. The only time we're going to do left or right is if it's a vertical line. And then below the line and below the line. So when you're solving systems of inequalities, it's really important to kind of follow these steps. If you go out of order, if you do something differently, it could get confusing because there's a lot of going to be two different lines and two different shadings on your paper, and you want to make sure you get them straight. So the first step is to solve each equation for y. Remember that if you divide by a negative, you have to flip your inequality. Determine the m and the b for each equation, and then I think steps 3 and 4 are the most important. For step 3, you graph and shade one line. Then for step 4, you do the next one. When people graph both lines and they have to go back to remember which is which, I see small little mistakes. So I would do one line shade and then the other line in shade. Okay, so let's look at number 1. For number 1, my first m is right here in front of x, so it's negative 1 over 1. And my b is negative 2. So I'm going to go down 2 and then down 1 over 1. Okay, and so now what I'm going to do is I'm going to draw my dotted line best I can, a little crooked. And then it says greater than, so greater than for this one happens to be up here. Because I know where it's at because I'm going to shade above the y-intercept. Alright, let's switch colors for the next one. So for my second equation, my slope is negative 5 over 1. Because it's right here attached to the x. And then my b is 2. So I'm going to go up 2. I'm going to go down 1, 2, 3, 4, 5 over 1. And so now I'm going to try and draw a dotted line through there. And it says less than, so I'm going to shade down below. And your answer is where you shaded both. And I'm going to shade that in black, because both answers are there. And so that is my solution region. It's where both shadings are. Alright, let's go to number 2. So for this one, my m is 1/2 and my b is 2. So I'm going to go up 2 and go up 1 over 2. I'm going to go the other way. This time, if you notice, it's underlined, so I'm going to have a solid line. And it says that it's less than, so I'm going to shade below. Now let's switch colors so we could see the next one. For the second equation, I have to move the 2x. So I'm going to minus 2x on both sides. So y is less than negative 2x minus 3. So my m is negative 2 over 1. Oh, what happened there? And my b is negative 3. So I'm going to go down 3, and then go down 2 over 1, and then I'm going to go the other way. This one, this time, you see that? That's going to be a dotted line. And I'm going to shade below. And so your answer region is where you see black and blue. Gray and blue. So my answer region this time is down here. Okay, let's do one more and then you'll have an opportunity to try some. So the first one, this one, you see how there's only one variable? It's either a vertical or a horizontal line. So I'm going to go where x is negative 2. And because it's on the x-axis, I'm going to go the other way. And so this is a vertical line and it should be dashed. Now this is the only time that we shade left or right, and x is greater on the right side. Alright, and then let's look at the next one. The next one we have more solving to do, so I'm going to add 3x to both sides. and I get negative 2y is greater than 3x plus 2. And then I need to divide both sides by negative 2. Now, here's the important thing. I divided by a negative, so I need to flip that inequality. And then 2 divided by negative 2 is negative 1. So my m is negative 3 over 2, and my b is negative 1. So down 1, 2, 3 over 2. Up 1, 2, 3 over 2. And it's a dotted line. And I'm supposed to shade. I don't look here. That's not the right spot. I'm going to look right here. That's what's important right there. That's the one I care about. So I'm going to shade below. And so my double shaded region is in kind of the bottom middle. So there's my solution area. Okay, what I'd like you to do is I'd like you to try number 4 and 5. And then when you think you have it, check your answer. Okay, so hopefully you got them and you understand what's going on. So I start down at negative 3. And there's no m. So that means it's a horizontal line, and it's dashed because it's just a greater than. And I'm supposed to shade above, so I'm going to shade up here. For the second equation, you should have divided by 3. So it would have been y is less than or equal to 5 over 3x plus 2. So your m is 5 over 3, and your b is 2. So I'm going to go up 2. And then up 1, 2, 3, 4, 5. 1, 2, 3. And we'll go the other way. 1, 2, 3, 4, 5. 1, 2, 3. And this one's a solid line because it's equal to. And it says less than right there. So I'm going to shade below. And then you can see where both colors overlap. Right in here. So that is the solution area. Okay, so for number, wrong button. For number 5, the first equation, your slope was 2 over 3, and your y-intercept was 3. So I go up to 3, and then up 2 over 3. I'm going to go down the other way. It's a solid line, and it says less than, so less than is below. And let's change colors. For the next one, it's another one that I have to divide by 3. And so y is greater than or equal to negative 4 over 3x minus 3. So my m is negative 4 over 3, and my b is negative 3. So go down 1, 2, 3, 4, and over 3. Up 1, 2, 3, 4, and over 3. And this one's also a solid line, so I'm going to draw my solid line. Oh, I made it through the dots this time. That's good. And I'm going to shade above. And so where the blue excuse me, and the gray overlap, that's our solution. So our solution area is pretty big this time. Okay. All right, same thing. I'd like you to try 6 and 7 on your own. And then when you think you're ready, come back and watch what I do to see if it's right. Oh, wrong button. Okay, so you should have went where x was negative 3 and recognized that it was a vertical line, because when there's only one variable, it's a vertical line. And this time it's less than, so it goes to the left. And then the next problem, again, another divide by 3. Lots of divide by 3 on this page. And so I get 5/3 x plus 2. So my m is 5/3 and my b is 2. So I'm going to go up 2. And up 1, 2, 3, 4, 5, and over 3. Down 1, 2, 3, 4, 5, and over 3. And this one's also a solid line. And this one we're shading below. So I shade below. And I find my answer right there in the corner. So my double shaded region is right here. That's my solution area for this system of inequalities. Okay, last one, same thing. Again, I find it much easier if you find your m and your b ahead of time. So find my And my B is 3, and I'm going to go up 1 over 1. And this one is a solid line. Whoa! Didn't mean that to happen. So this one's a solid line. And it says less than. So I'm going to shade below the line. And then let's take care of the last one. For the last one, the first thing I have to do is move the X. And don't forget I have a negative Y. I don't just have a Y, so it's negative Y is less than negative X plus 4. Well, that's a negative 1, so I'm going to divide by negative 1. And so I get 1x minus 4. And here's the thing, I divided by a negative, so I have to flip that inequality. So that's the one that I care about. So my m is 1 over 1, and my b is negative 4. So I'm going to go down to 4, and I'm going to do my line. And if you noticed, it is a parallel line. Usually parallel lines means no solution, but this one's different because I find where things overlap. So I'm supposed to shade above. So you should be able to see that the double shaded region is this region in between, because that's where both of them were shaded. So even if you have parallel slopes, you could still have a solution area. If the problem would have turned out like this, where one shaded above and one shaded below and they didn't overlap, that's an example of a no solution. So parallel lines can be a no solution, but it really will depend on where the shading is. So remember, when you do these problems, the first thing you need to do is solve for y, identify the m and the b, and then graph and shade one line at a time.